Hello, this is Mr. Miller, and it's time for video 3i. I hope you're doing great today. We're going to talk about two different types of tangent line problems and just practice them. First is the classic finding the tangent line to a function at a point, and the second is finding where the tangent would be horizontal. All right, we got three examples of each. Okay, here's our first example. In this problem, we want to find the equation of the line tangent to the function at the given point. So we have the function y equals negative x squared plus 5, and that's the blue parabola here. And our goal is to find an equation for this tangent, which is shown with the red line. In fact, we want to find the tangent at negative 1, 4, which looks like it'd be this point right there. That's the point where the line is tangent to the function. Okay, well, there are several steps here. The first step is find the derivative of the function. So step 1, find the derivative. So y prime equals, it'd be negative 1 times 2 times x, and the derivative of 5 is 0. So in this case, the derivative wasn't so bad, just negative 2x. The second step is to find the slope of the tangent line. We have to evaluate the derivative at the point. So, okay, the slope of the line would be y prime at, in this case, x equals negative 1. And that'd be negative 2 times negative 1. I'm just substituting negative 1 in for x in the derivative. And negative 2 times negative 1 is 2. Then the third step is to write the equation. We know the slope, we have a point, we can just use point slope form. So it'd be y minus 4 equals 2 times x minus a negative 1, which is the same as plus 1. And I'm okay with you leaving it like that. Textbook probably doesn't leave it like that. It probably solves it for y. I mean, we can do that too. That'd be y minus 4 equals 2x plus 2. If we add 4 to both sides, we get y equals 2x plus 6. Okay, that's the tangent line. All right, let's take a look at another example. This one has a trig function, y equals minus cosine x. And again, the function shown in blue. We want to find the tangent line at negative pi over 2 comma 0. That's this point right here. And again, the red line represents the tangent to the graph. Okay. First thing we need is the derivative. So y prime equals minus, because of the minus here, the derivative of cosine is minus the sine x. So minus sine x would be just sine of x. Okay, second step is to find the slope at the point. We need the derivative at negative pi over 2. So that would be sine at negative pi over 2. And the sine of negative pi over 2, I have to think here for a second. Sorry, a little brain fart. So I'll draw my unit circle. This is 0. Negative pi over 2 is actually this point on the unit circle. That would be negative 1. You could also use your calculator to find that value. I was just too lazy to get mine. All right, now, next step is write the equation of the tangent line. So y minus 0, well, that's just y, equals negative 1 times x minus the negative pi over 2, which is x plus pi over 2. And I guess we could write that as negative 1x minus pi over 2. All right. This one, a little bit more challenging because it's a rational function. It kind of involves the quotient rule. And the rational function has asymptotes at negative 2 and 2. And we want to find the tangent line at x equals negative 1, which would be about right here. So right there is where it's tangent to the function. Okay, well, we're going to need the quotient rule. So let's write that. F over g prime, the derivative of a quotient, is g f prime minus f g prime over g squared. So here we go. Y prime equals g minus f prime, that would be 0. I'm sorry, times f prime, minus f which would be 3, times g prime, 2x, all over g of x squared. So x squared minus 4 squared. Okay, 0 times that makes that all go away. That's going to be 0. So you get y prime is minus 3 times 2x, which is minus 6x, over x squared minus 4 quantity squared. Okay, we have to evaluate that at negative 1. So m equals negative 6 times negative 1 over quantity negative 1 squared minus 4 all squared. So that'd be 6. That would be 1 minus 4 is negative 3 squared is 9. That simplifies to 2/3. And the final knockout punch. We got y plus 1 equals 2/3 times x plus 1. That would be our equation for the tangent line. All right. Now, let's switch. We're going to do 3 of the other type of problems. For these problems, we're looking for all the points where the tangent line would be horizontal. That's actually all the points where the derivative is 0. So apparently this parabola has one point like that where the tangent line would be horizontal. And it looks like it occurs at 2, so we kind of know the answer already from the graph. But let's use calculus to derive it. So we got to take the derivative. So y prime equals. Here, this might be confusing a little bit. We can think of this as negative 1/2 x squared plus 2x. So it's minus x squared over 2. If you want to think of it as negative 1/2 times x squared. So when we take the derivative, 2 times negative 1/2 is negative 1. X to the first power plus the derivative of 2x is 2. Okay, now this is different than finding the tangent line. We want to find where the tangent line has 0 slope. So we want to know when this equals 0. So we have to set the derivative equal to 0. So if I subtract 2 from both sides, I get that. And if I divide by negative 1, I get x equals 2, which is what we expected right here. That's where the derivative is 0. All right, let's do a cubic function. A little bit crazier. But based on the graph, we expect to find 2 points where it has a horizontal tangent. Right there and right there. So it looks at x equals 0 and x equals 2 are the answers. So let's do it. Let's find the derivative. Then let's set it equal to 0 to find where the derivative would be 0 and the tangent line horizontal. So set it equal to 0. Now, when you're doing this, at least for the sake of this video, you can use your calculator. You could use the solve feature. But we could factor out something here. We can factor out an x. So I know we could factor out like a minus 3x, but just factoring out x is easy and that'll do the trick. So we get x times negative 3x plus 6 equals to 0. Then we can use the zero product property. All right, so either x equals 0 or minus 3x plus 6 equals 0. Subtract 6 from both sides and divide by negative 3. You get x equals 0 or x equals 2. So we practiced that at the beginning of the year, factoring out the greatest common factor or factoring a trinomial and setting the factors equal to 0. So if x is 0, this would be 0 times that, and that would make it 0. Or if x equals 2, the second factor would be 0. And 2 times 0 equals 0. All right, we got one more. This one involves the quotient rule. So we want to find where the function has horizontal tangent. Looks like 2 points. It looks like right there, kind of. And somewhere about right there. It looks like 0 and 2 again. Let's see. So the quotient rule says f over g prime equals g f prime minus f g prime over g squared. Okay, so let's do it. So y equals g would be 3x minus 3 times f prime, 2x, minus f times g prime, all divided by g squared. Okay, so that's y prime. So y prime equals, well, got some simplification. 2x times 3x is 6x squared minus 6x minus 3x squared all over 3x minus 3 squared. And so we get y prime equals 3x squared minus 6x all over 3x minus 3 squared. Now, we want to set this equal to 0 for this problem to find the horizontal tangents. Now, a fraction is 0 when the numerator equals 0. So we just set the numerator equal to 0. 3x squared minus 6x equals 0. Or x times 3x minus 6 equals 0. We get, using ZPP, x equals 0, or you get x equals 2. Looks like the last problem a lot. All right, so when we have a quotient rule, we get this, and we get kind of a rational function for the derivative. To find where it's 0, just set the numerator equal to 0. All right, that was a lot of math there. It's your turn now. So we got one problem of each kind. First problem, find the equation of the tangent line to y equals 3 over x squared minus 4 at -1, -1. You're going to need the tangent, or sorry, the quotient rule for that. For the second one, we have a cubic function. Find the points where the derivative is 0. Okay, good luck. See you in class.